year. I guess these projects took place like 2020 or something, beginning of pandemic. Anyway, so just a little bit of background. So this project was part of a sort of longer and ongoing research as well that is looking at 3D printing concrete. So what we are really sort of focusing on in this project from the beginning was, what does it mean when we go from casting concrete, which is the typical sort of production method, to depositing it in this robotically controlled process. So what does this mean in terms of how we design and how the material can form, what we can do with it. So what we identified sort of really on is that traditionally we design and think of concrete in these two main scales. The macro scale, which is in how the dimensions and the shape of the sort of building components around us, but then also at the micro scale in terms of the composition of the concrete mix. So both these two scales sort of affect how this concrete performs in the built environment. So then with 3D printing, what happens is that it opens up this intermediate scale that allows us to control how the material is placed and distributed three-dimensionally at the scale of the printing nozzle. So in our case, this is a 20 millimeter nozzle. So what this means is that it opens up new possibilities in terms of designing the material at this mesoscale, or in mesostructures, as we call them. And this could have certain, open up new aesthetic possibilities, but it also affects how the structural performance of the material or the functional performances like thermal and acoustic effects. But then the problem with sort of 3D printing, its typical workflow, is that we design a 3D model that then in sort of separate step is divided into these printing paths, these instructions that the robot follows. So in this approach, the print path is really out of control of the designer. It's just an automated step. So as a result, then you get these kind of very linear layers because this technology was initially developed as a desktop technology. So when you scale this up to building production, these layers become a really inevitable part of this sort of tactile qualities of the printed surface. So this, in my doctoral research, this was my sort of starting point. So this was a really limited use of the technology, and it didn't really explore its full potential. So what I did is just by sort of what happens if we then design the geometry of the line locally. So just by introducing these sort of alternative line paths to the print path, you could create these sort of these different results. So just by sort of alternating the layers and stacking them differently, you create these sort of perforated effects and inbuilt cavities in the concrete that we thought had a lot of potential. And if you think about it, this really then the 3D printing process is actually not very dissimilar from knitting, because it's this continuous filament that you arrange according to different patterns. And we thought just like a stitch is the sort of building block in a knitted fabric, the geometry of the print path could be the component, the building block in a 3D concrete structure. So this led to the development of a design tool together with my collaborator, Helena, where we then took different line types as a point of departure and introduced different parameters in how we then apply these three-dimensionally. We can change the wavelength, the amplitude of the patterns, and alternate them differently in terms of stacking. So this is a video that sort of shows the process where, so this tool is sort of integrated in a Rhino environment. So then as a designer, I can take decisions about the print path directly in a very early stage of the design. So in the NAVET project then, what we really wanted to do is like explore what are the static potentials of this design method or this approach. also integrate colors as a parameter in the design process. So for this purpose, we decided to work with clay. So this, because we don't yet have the possibility to extrude dual concrete, so this technology is not available. But what we did is we developed this Delta printer that has a dual extrusion with clay. So then we work in scale 1 to 2, and this is something that we have also done in the past. We work in different scales, either with the plastic extrusion or clay, to sort of simulate this print path, because to work with concrete is really a lot of work and a lot of cleaning and not a very creative process. So this was a way to really sort of be more playful and explore more options. So this is the finished machine. So this was one part of it, sort of the actual hardware. Also, we did some sort of color tests with clay. So we spent a whole summer down at the IFA Center art residency in Skåne, where they have amazing facilities for kind of ceramic work. But this also meant that we sort of looked at designing our design tool. So what happens with these different stitches? How do they need to adapt to sort of morph into different shapes? So these are some of the outcomes that we had. So like while we were down there, we also realized we needed to sort of, because we did dual extrusion, sort of one extruder was the leftover material was sort of soiling the next layer. So we took one of those nail brushes and put it next to the machine, and then also added this line in the code, so in between each layer. Then also goes this little brush and this little movement to clean its head, and then goes back and continues with the next layer. And then just to say like what happened after in this project. So while sort of going like very deep into this like aesthetic exploration, we also wanted then to see how this design approach, how we can control the structural properties of concrete. So this was a project called Digital Concrete that was financed by SBUF and Smart Environment that is still ongoing. So for this, we're interested in, as we have this possibility to control the three-dimensional structure of concrete as it's being deposited, we could use this to strengthen a building component where it's needed and have less dense structures where there are no loads. So, I mean, the whole hope with 3D printing is that it will lead to us using concrete in a more resource-efficient way. So this has led us to do a lot of sort of structural testing on these different kinds of mesostructures that we have. And it also, Jose just finished his licentiate with this, in where he actually took this design approach one step further and added the parameter of varying the flow of the material as the print goes ahead. So if the speed of it also slows down, you get a wider filament. So that can also be a way to strengthen a structure. So from this, he devised a sort of optimization method for concrete. So he applied this to beams, and where he found that he could make much more structurally efficient beam using less material by just sort of adding a wider filament